Hello everybody and welcome back. It's been a few weeks since I did an update video on the big laser here, and I did a lot of work covering things that needed to be done with that, and I thought I'd give you an update because there are more changes coming, and those will be big changes, and I want to put them into an extra video. So yeah, let me show you what I did. Because I've been increasing productivity a lot, and it was really simple. So let's have a look. So first thing that I did was I got myself a really simple sheet of steel. This is not anything special. This is just standard repair material that is used on cars and stuff. And I think it's 0.5 millimeters, and I oiled it so it just wouldn't corrode all over, and I cut it so it fits the table perfectly. And you can already see why I did that, because all of the stuff on here is what comes off material when you laser it. Usually that stuff would get stuck in the mesh under here, and it's really hard to get out. And it is also a problem because some of this stuff can actually catch fire, and it can catch fire later on, and you don't want to have a fire right in your mesh, because that is one of the biggest dangers that you're facing, that you're running the machine unattended and something under here catches fire, either acrylic or wood or a similar material, and you just don't want that. So what this piece of steel does effectively is it just makes sure that everything coming off the material you're cutting basically forms a condensate on the metal right away, so it sticks on here. Also, and it's probably hard to see, there is some free space back here, so the air can still travel over and under whatever you're cutting, and it makes for a lot cleaner cuts. You have a lot less of soot on your cuts, just because the air is now traveling under the whole thing, and it is much easier to form condensation on the metal than it is on the material you're cutting. Because, face it, everything in here in this basement is cold, and if this machine's been cooling for a long time, it is going to be turning cold too. So this was a huge improvement, and it was just this piece of mild steel that is lying in here, and it doesn't cover all of the material that's in. And simple thing, and it was a huge improvement. And over time, I haven't tried to get any of this stuff off yet. I expect that it's going to take oven cleaner or something to get it off, because it really sticks on here. But whatever I cut now looks a lot better, because I used to be having a lot of soot forming on many of my pieces, and that was basically coming, although this was not laying right on the material below it, this was a huge problem. It just doesn't look good. New cuts that I've been doing are completely clean on the underside. Like this one. This is the underside of the cut. It is completely clean. There's nothing on it. And the two things are, first of all, everything that comes off here, glue, what is it called? Humidity from the wood. Everything is just caught by the cold metal, because it can get down on that. And the fact that the air is now moving right under whatever I'm cutting also improves that a lot, because it just gets drawn away from the material. Very simple change, very effective. The second change that I did was a little bit more complicated, and it is still ongoing. This is the air pump that I had on my laser. It's the pump that came with the laser, and it did come with a US standard plug, but it's a 220 volt pump. What I did is I attached a single plastic bottle to this, and the reason for this is a pulse pump, so it just pulses pop 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 pop. If you put the air through any sort of container and air is compressible, you'll turn it into a more flowing stream. So you will have something blowing on your objects while you're cutting them, and not just going fup 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 fup. And it increases the quality a little bit, and is really easy to do. And I've used this for some time now, but I did some tests, and I used a compressor, and I put some compressed air onto the cuts that I was doing, and I pretty quickly found out that I can go a lot faster and with a lot less laser power the more air I put onto the nozzle, because it just clears away everything that is basically burned away, is just blown away so quickly that the laser is a lot more effective. And cuts like this one that look completely blackened, they're now a lot better, and the improvement is really, it's noticeable. I was able to, my standard cuts were 60% laser, 20 millimeters per second for 3 millimeter plywood. I can easily go up to 30 millimeters per second now, and that is like a 30% increase, which is really cool. So, no, it's a 50% increase. That is quite a lot. So that was a really good change. And then I started doing more stuff with that. And this is where it gets complicated, because the changes I was doing actually involve, that big yellow thing back there. That is my new air compressor. Unfortunately, it came with a slight flaw, and it has to go back. Too bad. But let's get back to this. I did a lot of changes with the materials that I've been using, and with experimentation, I came up with this. This here is a dehumidifier for compressed air, and on here I have something which is kind of similar to an air assist, but it's a bit different, and in the end it's going to be a lot different. This is just a pneumatic switch. So there's a magnet in here, and it opens the valve or closes it. And I found out that if I go to about, 0.8 to 1 bar, I get really good cuts. But I don't want to have this blowing full power all the time. And also I don't want the airstream to stop, because I don't want to get any vapors into the laser head, fogging up the lenses. So I did a lot of experimentation, and I built a lot of really complicated stuff to get a little bit of air from this side to that side. And in the end, I took my smallest drill, and I drilled a hole right through the wall in here. So there's a 0.8 millimeter hole through this pneumatic switch, and it's perfect. when the switch is off, I get a very slight amount of air going through the nozzle. It is not quite as much as the old pump was doing, but it's close to that. And then when I switch this on, and I do have the possibility to do that with the Ruida controller in here, or I could use one of the leftover switches on the front, because there is a standby switch that you can use for that. When I switch it on, I have an ample amount of air, and I can go to, I don't know, 1.2 bar of pressure, and I can really cut through almost anything, and it looks amazing. So I got a few more of these switches, and because this one is not suited for my laser, because this one is 12 volt, and the supply voltage and the control voltages on this laser are 24 volts. So I had to get different ones. I'm going to get two of them. I will have one to completely switch it off. If I power off the laser, the first valve is going to close 100%. And after that is going to be the second valve, which has the either slightly open or all the way opened setting. And that is going to be my two-stage air assist, completely off, or it's 3 stages, completely off, 20%, 100%. And yeah, I did try this with a small repair compressor, but the big downside of that one is that is incredibly loud, and it has a very small tank, so it's basically running all the time. Yeah, that's how loud it really is. It's really bad, and it's just no solution. So I went out and I got a new compressor. Unfortunately, that one arrived here damaged, so it has to go back, and I'm gonna have to wait for a new one to arrive. Coincidentally, like everything I've done with the laser, it was the cheapest compressor that I could get with the features that I wanted, and well, it fits the picture. Unfortunately, like my chiller, that one's broken too. But it's going to get replaced. It didn't come from China. It came from Amazon. So yeah, that is the things that I'm working on right now, and those are the changes that I did. I did tons of work on this thing, and everybody says your laser tube is not going to survive longer than 6 months. I can't confirm that. My tube is going strong. I've not had any problems yet. I've not had any problems with the machine going out of alignment. Everything has just been peachy up to here, and I'm really happy with it. And actually, I just wanted to keep you in the loop on the things that I'm doing right now, and what I, well, plan to go through doing in the near future with this machine, because it's an interesting project, and I really like working on this. When I got it, I didn't know how much you could do and how much you can improve from what you got, and how far this thing can go, and I'm really happy with it. I'm doing some other projects with it right now. Some of them are still kind of in secret, but it's a lot of fun. It really is. So thank you very much for watching, and bye-bye. So in case you were wondering what's wrong with this machine and why does it have to go back, well, it actually came with a pre-detached pressure connect to the compressor. So I suppose it must have fallen over during transport, hit this side hard, and I just took this thing off. I don't think I can repair this because this is brass and it's going to be real hard to get this out of the compressor. But apart from that, this is a really nice machine. It's 50 liters tank. It's I think 750 to 1000 watts. It is advertised as being I don't know, 59 decibels. I've had it running. It is really, really silent. It's okay. If this thing lives, it's probably really cool. Big tank, silent compressor, and I think it was under 180 euros. It was really, really cheap. It was the absolute cheapest that I can find. And it wasn't some shady seller, it's Amazon, 100%. Yeah, unfortunately it's bad. It's broken. And I didn't need this. I needed something that worked. But, yeah. So, I suppose a lot of you are asking yourselves, well, 59 decibels sounds great. Does it really have that? I'm not entirely sure, because it says it has an LWA value of 79 decibels, so let's see what is more accurate, 79 or 59. And to do that, we can turn it on. It's working. It just can't make any pressure because nothing's going into the tank. Incidentally, when they sent the tank, there was pressure in there, and it is still holding. So that's good. Well, let's get out the good old Brühl and Kjær decibel meter, and let's see what happens. So that's about a meter. And I would say, well, I think the 79 is much closer to what we're getting here than the 59. Too bad. Maybe it gets a little bit more silent when it's closed up. Maybe. But it's bearable. It's not that bad. Well, yeah. So much for curiosity about how loud it is. It appears to be around 76 decibels at 1 meter.